Okay, so this question is asking us to represent potassium oxide with a Lewis dot structure. So in order to do that, we have to think about how many valence electrons each of these atoms has. And then we also need to think about how many valence electrons their individual ions have. And so let's think about potassium first. Potassium would have one valence electron. It's in group one, but it loses an electron to become potassium ion. And so the Lewis dot structure for potassium ion is simply K with a bracket. And remember, we use brackets anytime something is charged. Well, for oxygen, oxygen would normally have 1, 2, 3, 4, 5, 6 valence electrons, but because it becomes a -2 ion when it's oxide, it actually gains 2 electrons. And of course, since it's a -2 ion, we want to show that Lewis dot structure in brackets. And so we would draw a -2 on the outside to indicate to the reader what the charge is. Now, we arranged the potassium ions sort of symmetrically around the negative ion. Whatever, in this case, whenever there is more ions, we would probably put those on the outside. Whatever ion is in the lesser quantity, we put those in the inside, although there isn't really a hard and fast rule about that. So for something like magnesium phosphide, well, I'm not sure what we would do with that. We would kind of just have to show everything kind of just spread out evenly as much as possible. And there's not going to be one right answer for how we would show that with a Lewis dot structure, but we would try to make it as symmetrical as we possibly could. And we would try to, spread out the magnesiums around the negative ions. And so there would be 3 of them. Maybe we would do it like this. This doesn't absolutely represent the individual formula unit of the ionic compound, but this is just how we would represent it with Lewis dot structures. Okay, hope that helps.